Hello everybody. In this video we're going to be covering one of the sections in chapter 5 of our text, molecules and compounds. In this video we're going to discuss how to go from a chemical formula to a name that we can call it, something that we can type out on the keyboard. I'm not going to lie to you, this is really one of the more annoying things that we have to learn how to do. It's really because we're still trapped to the symbols that we could easily type out on a keyboard. If people had a little bit more chemical literacy, you'd probably turn over a shampoo bottle and see just a bunch of chemical formulas, but you really don't. Instead, you see a bunch of names that have to be translated into formulas. And so this is a skill that we still need to work on here. So if we get a formula, we need to be able to name it. If we're given a name, we need to be able to derive the formula from it. There's a procedure to doing this from formula to name. Our step one is we're going to ask ourselves, is the compound one of the exceptions to the rules? And the exceptions to the rules come in the form of what we call common names, things that have just been around so long that we have established names for them. For instance, H2O, if we called it by the proper naming convention, would be dihydrogen monoxide. But we don't call it that. We just call it water, steam, or ice, depending on its phase. NH3 would be nitrogen trihydride, but we call that ammonia. CH4 would be methane. NaCl is table salt. And C12H22O11 is just what we call table sugar. So first, if you can recognize one of these, then you can just name them right off the bat. But if that's not true, then we have to go to step 2. And the step 2 is basically we're going to try and break it up into some boxes. So we want to know, what major class of compound is it? Is it an ionic or is it a molecular? So ionic compounds are going to contain a metal and a nonmetal, okay? And the metal will be the first thing in the formula. So whenever you see a metal, the first thing you should say is, oh, this is an ionic compound. And then you can kind of think about if it falls into one of these two groups here. Is it a binary ionic, meaning there's no polyatomic, or is it one that actually has a polyatomic in it? Then we have our molecular compounds, and this is going to be indicated by the fact that there's no metal. So there's 2 or more non-metals. And then it could be a binary molecular or binary covalent, they might call it, where we have 2 nonmetals bound together, or it could be one of the acids, which is going to have a formula that starts with an H, a hydrogen. Though acids are molecular, they behave as ionic when they dissolve in water, and they may be binary or they may be oxyacids. So there's some subgroups in the acids. So once we figured out what the major class of the substance is, we have to figure out what subclass it is. So we're going to break this down even further. Okay, so we have binary ionic or ionic with polyatomics. We have a binary molecule. We have a binary acid, or we have an oxyacid. So when the compounds contain a metal and a nonmetal, they're what we call a binary ionic. And these come in 2 types, type 1 and type 2. And we'll talk about what those are in just a moment. Compounds containing a polyatomic ion, these are ionic with polyatomic ions. So as soon as you see a polyatomic, you know which one it is. Compounds containing 2 nonmetals are going to be your binary molecular compounds. And compounds containing a hydrogen and a nonmetal are going to be your binary acids, whereas compounds containing the hydrogen and a polyatomic ion are going to be our oxyacids. Okay, so now we figured out what class and subclass we're in. We're going to have special rules that apply for each and every single one of them. And I'm going to be covering those in a series of other videos to try and kind of break it down for you a little bit. It's really not that bad, but you do kind of need to take it in little chunks.